que tu as une blague drôle en tête?
The weather is nice. Huh? Yeah, yeah. I'm really not good with jokes. Where is Carlos when we need him? Are we good? Okay. So, guess we're good. First of all, welcome to another edition of Require LX. Last one was in July, if I'm not mistaken. So this is the November's Require LX. Today we'll have topics around Rust, Rust tooling, which also is very correlated with JavaScript ecosystem. So don't worry, this is still JavaScript focused meetup, but you'll see soon that Rust is still very entangled with JavaScript. So we'll have topics from building applications for your every OS that you want to, or even WebAssembly. So yeah, welcome, and I will pass the mic to Sylvia, which is there.
Thank you so much. It's always great to see the room as we have here. I admire and I love this to have, in an evening like we have at the moment. And we are here. We are here to learn. We are here to exchange. And I truly believe that brings also a lot of happiness on us when we are doing those things together. That's really what I believe. I'm going to talk to you a little bit about Mercedes-Benz I/O. It's a pleasure for us to host this event here. And it's a very recently picture of our tribe here in Lisbon. BIO, we have other locations, but here in Lisbon and also in Braga, we have here in Portugal, we are around about 460 people, and this was our pit stop when our people come together to talk about products, to also have fun together and to exchange. This is one moment that you have once a year. And I have here on my side the mission of Mercedes-Benz I/O. We say we ignite and build the digital solutions for Mercedes-Benz. What does it mean? Everything that we have in Mercedes-Benz in the areas of sales and after sales and marketing, the digital elements are going to be done by Mercedes-Benz I/O. So this takes a very high responsibility. I think here we have a lot of front-end developers. Imagine Mercedes-Benz I/O is responsible for the whole online store for Mercedes-Benz. I'm thinking that Mercedes-Benz is not just to sell electric first, but electric only. So all the electric cars until 2030, we are going to convert them. So, and we would like to sell them online. Imagine how much potential you have in this journey together. No? And we say, how do you do that? You do this by forming a tribe of digital enthusiasts that drive the Mercedes-Benz digital future. And I think I have also the pleasure to have some people from this tribe here with us. Just raise the hands, maybe who are, I'm Bioneers here. Cool, very nice to see you. And also for us, it's extremely important, exactly this learning path, continuous learning, fail, take lessons and share with them. And also very glad today to have you, Rafa, with us, sharing also something from your journey. Here I talked a little bit, a lot about the 4 locations. So we have on top of Lisbon and also Braga, you have Stuttgart and Berlin. I'm the global CEO, and in total we are 660 people. And if you're looking at our community, that's a lot about tech. So front-end developers here represented 15%. It means 100 front-end developers, so a very important here responsibility in this context. And then we have, I would say the shot, we have 50% of the people are really tech, and then the agility profiles. We work with also the scale framework, so we have here everything around product owners, scrum masters, release train engineers, and so on. coming ahead, a little bit about some products that you do. I already talked about our online store, as mentioning, no? We are going to convert the whole electric. So, and do you sell electric car? Yes, we do. And we have the aim to sell 25% of our products to 2025 online. So it means what happens, you go to the journey, check the car, have already a contact with the whole digital product, and then you go to the dealer, you do your test drive, continue your journey at home, and then you can, have the handover again at the dealer. So it's this moments online to offline. It means it's extremely important then to also have here this responsibility as developers. I say, if our store is not working in the future, what is happening? We're not selling our cars. So it brings us here and all the developers in a very high responsibility together. Then we have also here the examples of the car configurator. I don't know if you haven't tried yet. Just go to our store, check if it's good, if maybe also some advice for us, if you can do something better, but try to configure your car. It's a very complex element doing by us. And also every single web page that we have in the world, exception in China, is also done by our people. Online appointment booking is also one service. Yeah, I'm not going to go longer on this because the night's for you. It's to share your information here. We are going to have, I think, very interesting sessions, but I'm going to be around. Anything that you also want to know or to talk, it's going to be a pleasure. Thank you so much. Wish a lot of learnings and fun.
Thank you very much, Sylvia. I'm sure that everyone,
Sorry.
no worries. I'm sure that everyone will go into the configurator and order their Mercedes EQS tomorrow or sometime.
At least try the journey.
Yeah,
We just launched the whole leasing, and our aim is very high, so 5 clicks to buy and clicks to find. So just look it.
I'll just drop my 80,000 real quick in 5 clicks. Okay, so thank you very much for hosting Require LX. So, as you know, I am part of YLD. YLD is, let's say, the main organizer, major organizer of Require LX. Obviously, this is a meetup that is very open to the community, so we always appreciate the community whenever they want to help. So please do help if you want to collaborate in organizing future Require LX. There's a ton of companies that also participate, like Mercedes-Benz, Volkswagen in July. So please do contact us if you want to collaborate. So now to talk about a bit of YLD and who we are, I will invite Maria to the stage. So, yeah.
Hi. It's working? Okay. Okay. I'm gonna trust the process. Hi everyone. I'm a bit nervous. But yeah, as Afonso said, I'm also part of YLD. And I'm just here to give you a quick briefing on what we do. Basically, YLD is a software engineering and product design consultancy. We work a lot with clients across tons of countries, very UK, very US focused. We work in a bunch of different industries as well. And currently, our focus is basically to help our clients optimizing their products with the best engineering teams, design teams, platform teams, and other people that we can find to help them. We're currently based in Lisbon, London, and we also have an office in Porto, where Afonso is from. And we're currently around 110 people, just basically using these events to do a bit of knowledge sharing, which is also a big part of our internal mindset as well. And I would say that's basically it. you.
All right. Thank you very much, Maria. So let's take another look at the agenda, right? So we have the 7 p.m. intros. Yeah, we're good. Just like a few minutes late. Then we'll have Rust, a brief intro with Miguel Palhas, software developer of Subvisual. Then we'll have the second talk, WebAssembly with Rust, a JavaScript developer's journey by Rafael Marques from Mercedes-Benz. And then we'll have a break. And after that, the third and final talk, from Rust to Rich UIs, exploring Tauri for cross-platform applications. So, without further ado, I'll call Miguel to the stage. Where is Miguel? Yeah, there he is. No, this is.
Yeah, but not sure if this one is just for recording.
No, yeah,
Okay.
you're good.
All right. Hello. So my name is Miguel. I'm from Subvisual. So Subvisual is a software development company from Braga, but technically we're fully remote nowadays. And I guess my job here is to explain to you what Rust is, or to entice you into Rust in 20 minutes or less. So let's get to it. So first of all, I'm going to start showing a little bit of what Rust is used for nowadays, because it's no longer just the systems language, low-level language that it started as, even though that's still one of the main focus. But as we've already seen from the index of the meetup, there's things like Tauri, which allows us to create very rich cross-platform applications. I'm not going to go into this. There's going to be a whole talk about this afterwards. Typist is also a really cool project. I mean, there's a very high chance that these are the first slides you're seeing written in Rust. Technically, it's if you know LaTeX, this is a much better version of it from the 21st century, and I'm a big fanboy of it. And there's also a really big ecosystem of CLI tools and developer tools that are essentially rewrites of existing things, but with much better features, performance, and stability, and built in record time due to some of the things I'm going to show here. And in the meantime, also something that kind of inspired me to do this talk a few months ago, or the first version of this talk, where there was a lot of discussion online. If you know this article, you maybe know what I'm talking about. Where there was a lot of debate around this time about whether types are useful, whether they're just a hindrance and stuff like that. And I found some really cool arguments and some really not so cool arguments. But essentially, and to condense 30 years of software development into 2 slides, we went from this, which is what I used to deal with in C, C++, to this, which is much more readable, but still not okay, in my opinion. And this happens, well, TypeScript, of course, improves a lot of this, but it doesn't fully solve these kinds of things. TypeScript can only go so far because it still runs JavaScript underneath. And so hopefully I can convince you that Rust is a good option for a lot of cases. So before getting into Rust, just one brief comparison. There are actually 2 kinds of typed languages. Well, there are more, but for this purpose, I'm going to focus on 2. There are what's called structural typing languages, where TypeScript fits, and other languages like OCaml, where the types of your data are defined by the shape you give them. And so you can combine different objects and with different types as long as the shape matches. So in this case, even though foo is not the same type as bar, it fits. A foo fits into a bar because it also has the X property, which is the only thing needed here. In Rust, we used what's called nominal typing, where that doesn't happen. The types are defined by the name we give them. Even though the shape may be exactly the same or very close to it, they're different types, semantically speaking, so things would not compile if we try to do what was in the previous slide. There are ways to convert between types, and this conversion can even be free, or it can turn into a no-op in runtime, but it still means we need to handle those cases. And this is both, of course, there are advantages and disadvantages to this, of course. So first of all, I'm going to focus on, or the meat of this talk is me listing 4 or 5 different things of what, for me, makes Rust a good language, or in fact, my favorite language by far, where the first of all is type inference, or type inference, never really know how to pronounce this. So if you're familiar with TypeScript and a lot of other languages nowadays, you probably know what this is. So type inference is the ability for the language, the compiler, the language server, etc., to infer types without you having to explicitly write them. And this is really widely adopted nowadays. So these are 2 snippets of Rust code. We don't need to read the first one. The one below does exactly the same thing. It's what you would write if you're writing Rust. No one writes Rust like the above. But they're both equivalent, unless I made some mistake, which hopefully I didn't. And Rust is able to, actually, yeah, there is a mistake that I forgot to fix in these slides. In the first example, we're listing everywhere that this is an array of 32-bit integers, and that each element is a 32-bit integer and so on. But because we're doing operations where we can infer the type from one step to the next, we don't need to do this. As long as one place is well defined, which in this case I forgot, so that's why the example below wouldn't work in isolation. But the compiler can then infer that if this is a 32-bit integer, then what comes out of the map is also a 32-bit integer, and so on. And so we rarely need to define types anywhere, with the main exception being function headers, which is where even the compiler sets a boundary. So it actually forces us to write the full type definition in a function header. And this is both to force us to document our code, because the types serve as very good documentation, and to impose a boundary on the compiler to also simplify the compilation, because the compiler now knows that anything inside a function, maybe it can try to infer the types, but it won't have to go past that, and which would get into a whole lot more complexity at the compiler. And of course, any place where there's ambiguity, like where the compiler can't detect the exact type that should fit there, if there are 2 or more options, then we need to be more explicit. Second, and I would guess this is the most out of the box and the most interesting thing, is memory safety, which applies, both memory safety and type safety in Rust apply also to multi-threaded code, asynchronous code, and so on, which is a really cool thing. That's, yeah, Go and other languages do some things along those lines, but I believe Rust was the first one and by far the most powerful. So this example here, it fails to compile. I'm not sure if you all know what a reference is. Maybe people from Java, JavaScript are not familiar with that. But a reference is a pointer to some other existing piece of data. So X is a variable. R1 is a reference, in this case, that points to X. So it doesn't allocate any extra memory. It just points to that number that already exists. And then R2 is also a reference, but a mutable one. A mutable reference is a reference that allows us to change what the reference is pointing to. And this code would fail to compile because we're trying to take a non-mutable reference and a mutable reference to the same value. The compiler doesn't let us do that, because then we won't have assurances that the non-mutable version won't change, because it's supposed to be non-mutable, but then there's another reference somewhere that is mutable, especially if these 2 references were separated across 2 threads pointing to the same place. This would lead to inconsistencies, deadlocks, race conditions, all that stuff. So by definition, Rust doesn't allow us to have conflicting references to the same memory area. This can get a lot more complex. You can slice arrays into multiple different slices and mutate each slice individually, but as a brief example, this is it. And the multi-threading safety and the type safety as well, I guess, is mainly explained by these 2 traits. A trait is similar to an interface in other OOP languages. This is an oversimplification, but it'll do. So if something implements the send trait, that means that it's a value that is safe to send to another thread. Sorry. If it doesn't implement the send trait, then the compiler won't allow us to create a thread and send that value to that thread. A safe value to send is, for example, an atomic reference counter. A mutexes sync is not send, sorry. And then a sync is a type that is safe to share between 2 threads. So note that sending from one thread to another is different from sharing a value while 2 threads are running simultaneously. So things like atomic values, mutexes, and all that sort of stuff. You need to combine these values in order to produce values that are send and sync, and only then can you send them across those threads, and the compiler will enforce those things for you. This I think, is the key part, is this enforcement. In C, C++, you also have all these primitives, but if you can easily go around them and write code that it maybe works and maybe runs in development, but it will fail in production a year from now, Rust doesn't let you do that. It enforces very strict rules, and it kind of, in my opinion, it forces you to write better code. Thirdly, the compiler, which is probably the most powerful compiler in any programming language. And I have 3 points here, but they're very intertwined. They all kind of relate to each other. So in essence, this is just one big point. First, zero-cost abstractions, which is something very widely discussed in the Rust community. So because Rust has a very powerful compiler and a very powerful type system, it allows us to do very complex things at compile time that will translate to very safe code at runtime without having any kind of hit in runtime performance. So there's a lot of things that in scripting languages, for example, we would do additional validations or additional logic at runtime to ensure that the data fits the type that we expect or that is correct and so on. In Rust, there's a lot of instances where we can do that at compile time, ensure that the types that we're receiving are the types that we want, forcing ourselves to deal with the errors in case they aren't. And then a lot of that overhead, those verifications can get eliminated in the runtime code, which leads to much more efficient runtime code that still has the assurances because it went through the compiler and the type safety validations and so on. And this leads to the second point, which is this often used quote, if it compiles, it works, which is not something to be taken literally, but it's something that actually happens a lot in Rust. It happens in Haskell as well. I think that's where this idea came from, which is this feeling that while you're programming, you don't even need to run things to have the browser showing the output in real time and to interact with things. Maybe you're running tests, but usually you're just running the type checker. And there's a strong sense that once you get the compiler to accept your code, there's a strong likelihood that it actually works. Of course, business logic can get in the way and can still be wrong. But this is just a very strong feeling that once you write good Rust code, this actually happens. And thirdly, and kind of to drive home the other 2 points, this idea of making illegal states unrepresentable. So because we have all these powerful compile time checks, there's this strong idea of using those type checks to make sure that our code is only in our data structures are only in a state that is considered valid, and any invalid states will be rejected. There's also this idea of the type state pattern, which there's a blog post here that goes into a lot of detail and has some great examples. You can take a look later. But to illustrate this concept a bit more easily, let's imagine an enum, a type that can be in 3 different states, an account state. So an account is either active, inactive, or banned. And depending on the type, it has additional properties. So an active account has an email and a date, the last date where it was active at. And a banned account has just a reason. We delete the email, maybe for compliance reasons. And notice that the email field is not a string. It's an email. And the email is declared down here. It's a type email that wraps a string. This is what's called a new type, the thing I mentioned in the previous slide. And at runtime, this will just be a string. The fact that this is a separate type won't take up any extra space in memory. It won't do any additional logic to instantiate a string. At runtime, this will be a string. But at compile time and while I'm writing the code, I can't just instantiate this type with a string. I can actually enforce how I want this type to be created. So for example, I can enforce that a type email can only be created if I pass an email that's going to go through a regular expression to validate that it's a valid email. And therefore, I'm making it impossible anywhere in my code to instantiate an email and therefore an account state with an email that is invalid from the get-go. So again, of course, that regular expression that will still exist at runtime, but all the logic wrapping the email type and the fact that the email is just a wrapper to a string, that will be completely gone by the time we compile our code. And number 4, the tooling, which is also a really comfortable part of Rust compared to other languages. Of course, there's been improvements in many areas, but in Rust we've had this from the start. We have mainly the tool we use is Cargo, which is a tool used to do 99% of things. It's used to build our code, to build to different targets, to WebAssembly, to different operating systems, different architectures. It's used to format the code, to test codes, to run either nightly or stable, which are the 2 different release channels of Rust. It's used to run our code even in workspaces with multiple binaries being compiled. The other 5%, or whatever I said before, is tools like Bacon, which is just a handy tool that I usually have on my side, which is just a wrapper to all these things before and just is used to clean up the output a little bit better. And there's, of course, things, I actually don't remember, yeah, I don't have a slide about that, but there's things like the Rust Analyzer, which is, in my opinion, on par or even better than the TypeScript language server. There's Clippy, which is a linter that's also, it does things that I wouldn't expect a linter to be able to do before I started using it. It's actually a really, really smart project compared to linters from other languages. But okay, tips to get started. So hopefully some of this may have enticed you, at least 1 or 2 people. That will already be an achievement. But there's still a lot of foot guns when people get started in Rust. And mainly it's that they get too much into Rust. So essentially, if you're writing stuff like that thing in the first line, that foo a, which I'm not going to explain here, that could be a whole talk on its own. But if you find yourself writing that kind of stuff, that means that you probably went too far into all these Rusts, all these smart features of the compiler, and that you can probably get around with doing a much simpler version. Just compile just clone your data, just unwrap your data. Don't worry about making it the most efficient version you can do. Worry about making it work at the first time. And then with the help of Rust Analyzer and the compiler, you're going to learn a few things here and there, how you can optimize it, how you can remove a lot of those things. And once those things click, all of this will be a lot faster to do. The tooling is built in such a way that it actually helps you learn very well. And second, finally, I don't think I have time for this, according to my timer at least, but it's something that we can discuss afterwards in questions. I want to also leave time to watch the rest of the talks. But it was just a couple of pointers about some of the counter arguments usually to Rust and maybe the counter arguments to those. So thank you.
Does anyone have any questions?
Hello.
Hello.
Congratulations. What are the different targets where you can compile some source from Rust for different computers and
different CPU architectures,
yes.
Different operating systems, compiling to WebAssembly.
There are computers for every destinations.
Sorry?
There are compilers for every destinations.
It's the same compiler.
Yes.
You just specify the targets.
Okay.
It probably doesn't support 100% of the targets if you go really far into history, but a lot of them.
Even application APK to upload to Play Store or something like this.
Sorry.
You can even create application with APK with destination
For Android.
For Android.
Oh, for Androids, yes. There's a few details there. You can compile binaries that run in Android architecture. If you're trying to write GUI applications for Androids, Tauri from the third talk, I think, also has a mobile plugin. There's a lot of options, yeah.
Thank you.
Thank you. Any other questions? There. The microphone is for the stream, by the way. It's not for everyone.
You mentioned that Rust is your most loved language, right? But before learning Rust, what was it? And a couple chain questions on that. Like, do you still love that previous language? Or was it in your scale compared to Rust? And how long did it take for you to get proficient with Rust? Like when starting from that other language that I don't know.
Okay, tricky question there. So the first time I learned Rust was 2014, was pre 1.0 when the language was breaking every week and I got fed up a bit. I started using it more full time around 2020 during a side project in pandemic. My background is I started as high performance computing, C, C++, CUDA, went to work into web development, Ruby, then Elixir, mainly those, of course, a lot of JavaScript and TypeScript along the way, and nowadays Rust. I was also always kind of fed up with lack of types in those languages.
Thank you for the question. Any other questions? I am the sprinter here.
Thank you. Good night. Which type of this was your side project? Because as I saw, we have some specific cases or specifically we can improve our development. Like, I don't know, could you explain more about your, I don't know, side project or which project you are working right now in Rusty?
So right now I'm working on a Tauri application, which has a lot of complexity to it, but maybe we can discuss that later if you want. But in my main job, I'm currently doing high performance WebSocket server and client for a protocol that I'm trying to develop. I can't really say more about that. This side project that I mentioned during pandemic was a wrapper. It was a binding to FFmpeg, the video processing library, and OpenCV, the image processing library. And I was trying to create a fake webcam in my system so that I could have Zoom, which in Linux didn't support virtual backgrounds, to support virtual backgrounds via my program. It was a stupid thing. It kind of worked, but the fan would go crazy every time I turned it on.
Okay, any other question? Oh, I should have stayed there.
Yeah, first of all, thank you for the presentation. How hard would you say that is to migrate a project that is like in mid-size, let's say, that is written in C or C++ and to go to Rust? And is it possible to have somewhat of interoperability between both languages?
With C, yes. With C++, it's a bit more tricky, but it can be done. And so for those languages, so migrating from C to Rust, it can be done by steps because you can have bindings from Rust to C. So you can still reuse your existing code. But migrating from some other language like JavaScript to Rust, that would probably be a full rewrite.
Okay, thank you.
Final questions? All right. Thank you very much. Thank you. All right. So, as you know, there's a lot of tools that are built with Rust. So definitely give it a look. There's like even runtimes now, right? Dino is written in Rust, for example. There's SWC. Dprint, which is like a prettier replacement, Biome. There's a ton of Rust tooling showing up, and it's actually taking over the whole JavaScript ecosystem. So yeah, pay attention. And now we'll have Rafael, which will present WebAssembly with Rust. So I call Rafael to the stage. Oh, there he is.
Let it here. So, thank all of you guys for having me here. Such a pleasure to be presenting this topic. I'm not that rusty programmer, so I kind of bring it a little bit more to the front-end side. So probably what we're gonna see here is more like about what I do on a daily basis. So with no further ado, I will talk about WebAssembly with Rust. And first of all, just introduce myself a little bit. So my name is Rafael Marques. I work here at MBIO for almost 2 years as a front-end engineer at Sela Center, which is an internal team that we have. I'm 29 years old, I'm from Brazil, and I'm just living here. 2 ways to contact me. The first one is my LinkedIn, and the second one is my email, my personal email. So if you want to contact me, just like send a message, my email, something, I'll definitely answer you. I'm not promising that I'll do it fast, but yeah, I'll answer you somehow. So let's jump into a more technical topic. And we're gonna start with a more generic question like, what is WebAssembly? Because we're gonna talk about it, I guess it's important to bring some common knowledge about it. So what is WebAssembly? And we're gonna see this like change of wasn't in the presentation, so it means the same. It is the like short way to say WebAssembly. We're gonna find it a lot of times in documentation and so on. So WebAssembly is a binary instruction format that enables high-performance execution on browsers, on web browsers. It's designed as a portable target for the compilation of high-level languages like C, C++, and of course Rust, which is the one that I will be presenting today. But definitely we have a lot of other supported language here that we can compile to WebAssembly, targeting WebAssembly. But this is the most famous one that we already have like some good support. So we do know a little bit of what is WebAssembly and what is its goals like. So I just brought 4 of the goals here, which is basically defined by the WebAssembly. The first one is be fast, efficient, and portable. So WebAssembly code can be executed at near native speed across different platforms by taking advantage of common hardware capabilities. The second one is be readable and debuggable. So WebAssembly is a low-level assembly language. However, it does have a human-readable text format that allows code to be written, viewed, and debugged by hand. So the main goal of WebAssembly is to try to make it like faster compilation, faster performance, and this is one of the reasons why it is faster, because we do have this WebAssembly in low level, so it means that the machine will not need like to translate this code to a machine level. It will be closer to the machine level, so it will be faster. We're gonna talk, I will talk a little bit more about performance in future slides, so it's just like an introduction about it. The third one is keep secure. WebAssembly is specified to be run in a safe sandbox execution environment, like other web code, and it will enforce the browser's same origin and permission policies like we have with JavaScript and everything that we are using right now in web browsers. And the last one is don't break the web. So WebAssembly is designed to play nicely with other web technologies and maintain backward compatibility. I guess this is one of the most important things in the WebAssembly, because when we're talking about developing a new feature or a new thing or using new technologies, it's kind of a deal breaker when we have like to learn and to go through this new technology and change everything that we have to this new one. So with this backward compatibility, it just means that we can write WebAssembly and integrate this code into our JavaScript application. So this is one of the strongest points here with the WebAssembly. So right now, we already know a little bit of what is WebAssembly, what is its goals. So the question is, why we should consider to go to WebAssembly? So the first reason that I brought here is interoperability, which is basically related to the thing that I just talked right now about backward compatibility, yeah. So interoperability basically is that WebAssembly was released, and the goal of this release was not like to substitute the JavaScript. It was like to work with the JavaScript. So you don't need to choose like between one or another. You can use both together in the same like application, and you can just use like the best part of each one. So this is the good point about it. The second part is language diversity. And it brings a little bit of a tricky good point, because it brings a lot of cons also, especially when we talk about language diversity. We think like in a magical world where we're gonna select like different languages and bring only the good part about this language, where we're gonna have like the best part, I don't know, about C, about C++, C#, and so on, and Rust. And then it will be like magic. We'll have like the most performatic code ever, and that would be magic. That would be awesome. But on the other side, we have the reality where we need developers to know all of those languages. And we need to think about that when we decide to go through this technology and through this way of doing, because we can create silos between our teams. We can create like some problems there. We need to do this kind of trade-off, thinking about like if it is or not the best decision that we need to go. And we need like to decide if it's good or bad for us. And the last one is performance. Performance is one of the things that we most talk about when we talk about JavaScript and web browsers, because JavaScript is such a language that brings like a lot of facility for us, especially for developers. So the cost of it, I guess, is performance. But when we talk about performance, why was WebAssembly so much faster than JavaScript? So just brought here 6 of these reasons why WebAssembly is faster than JavaScript. The first one is fetching. So fetching WebAssembly takes less time because it's more compact than JavaScript, even when compressed. Basically, what I'm saying here is the code that we're going to have in WebAssembly compiled will be a binary code. So it will always be like smaller, and will always take less time to fetch this code to the browser, to wherever you're running your code. So especially in slow connection. So this is one of the things that we should take in consideration because it will be so much faster. The second one is decoding. So decoding WebAssembly takes less time than parsing JavaScript. The third one is compiling. So compiling and optimizing takes less time because WebAssembly is closer to the machine code than JavaScript and already has gone through the optimization and on the server side. So what it means is that when we compile our code, when we build our code in JavaScript, we are building it, then the browser gets this code, transform this code into a binary code, but it takes time. So the bytecode, but it takes time because it is like a whole process to go through. When we write this code in WebAssembly or another language aiming the WebAssembly, it means that we are compiling this code to a binary code where we'll be closer to the machine code. It means that this layer between the machine and the code that you've just written will be closer, meaning that will be faster. Re-optimization. Re-optimization doesn't need to happen because WebAssembly has types and other information built in. So the JavaScript engine doesn't need to speculate when optimized the way it does with JavaScript. So in JavaScript, we have this strategy called re-optimization. Basically, it assumes some behavior on your code where based on your functions, based on the compiling and the optimization process, it try to pretend and try to see, try to imagine how your code will behave, and then they try to optimize it, but then you need to run it every time to check if your this prediction were right or not. So if it was not right, it will run again, so it is the re-optimization process, and in WebAssembly you do not have it because it's already like compiled and optimized like from the first time. The fifth one is execution. Execution often takes less time because there are fewer compiled tricks. WebAssembly set of structures is ideal for machines. So here, when we are developing code in JavaScript, especially when we're developing like for humans, we are developing it to be human readable. And when we compile this code, when we do this strategy, thinking about the developer experience, for the compile, for the bundle time, is sometimes the compiler do not understand it very well and it takes a little bit more time to compile it in the most optimistic way. So it takes more time to execute the code. On the other hand, with the WebAssembly, as it is already like a binary target language, it is compiled. Thinking about that, it is like made for this optimization to be done like in execution. So you don't need to think about that. And the last one, garbage collector. The garbage collection is not required since the memory is managed manually. So in WebAssembly, we do not have the garbage collector, and JavaScript do have. So it kind of creates this unpredictable behavior on the JavaScript because we don't know when this garbage collection will be run or not. So there's some schedules already in the web browser and the JavaScript engines where it tries to optimize this time to garbage collect, but sometimes it happens like where it shouldn't, like you're running like a high cost function and you run the garbage collector, so it stops running your function, so it kind of, it's unpredictable. So it's harder for us to think about how your code will run, how it will be executed. So this is 6 reasons why the WebAssembly is faster than JavaScript. So right now we have these reasons, and so we can jump into the Rust with the WebAssembly. So as Miguel already mentioned, we can compile the Rust code focusing and aiming the WebAssembly. And here's one of the reasons why you should take in consideration going with Rust when we talk about compiling code to WebAssembly. There's one reason that I didn't brought here, which is that Rust was one of the earliest adopters of WebAssembly. So the community kind of started programming and started developing a lot of tools for it. So it makes like a lot of lessons learned, a lot of process that the other language still not reach there. So it's a good point. The performance is obviously one point. So Rust is known for its low-level control and zero-cost abstractions, making it ideal to high-performance applications. The safety, the Rust ownership system eliminates many common bugs, providing a safe alternative for web development. So this here is one of the most important things. We're not like putting another technology to introduce bugs here. So with the safety and ownership system that they have, it kind of reduced the risk of it. Of course, there's a risk because in real world, there's a lot of possibilities, but it just reduced it. Interoperability, so Rust can seamlessly interface with JavaScript, allowing for easy integration with existing web applications. I'll show a code here, and you will see this interoperability between the Rust and the JavaScript. Community support, activity community, documentation, and learning process. So this is a very important thing that sometimes we just oversee it because we don't take a lot of consideration into it. But at the end of the day, in the daily basis, the developer experience changes a lot by the community support. So when we have like this active community, documentation, the learning process. So if you go to the Rust documentation, it's like very well written. They change a lot, they are releasing a lot. So it means like that it's something that we need to take into consideration when we are choosing a language to go on. And the tooling, there's Cargo that Miguel already presented. That was in BindGen, which is the one that will create this interoperability between the JavaScript and the Rust. And there was Unpack, which is basically a crate. They call like libraries crates. So it is a crate that will be responsible to compile this code in Rust to WebAssembly. Then it will be available in JavaScript. Then we can use this code and integrate this whole thing. So code time. I just brought a simple example here. This is just like an example from scratch to integrate your code with your JavaScript application. So it's very straightforward and a very simple one. This first command here is just to install Rust into your machine if you haven't done it before. Then we're gonna start install the was_unpack, which is the one that I just mentioned before. Will be responsible to compile this code to the WebAssembly, to your Rust code to WebAssembly and then to JavaScript. Then it will be available for us. After that, we can create the project. So we just run this command here, cargo new lib, which will be a lib. And then the name of your project. I was very creative and just would require a Lex example. Then we're gonna start writing Rust code. As you can see, my Rust ability is not that good, so I just write the simple one here. But this is a very basic code which basically import the was_BindGen crate, the one responsible to do this interoperability between the JavaScript or whatever code you are running. So basically we here are going through, I don't know if I can point it. Well, let me try to use the mouse because, okay. So basically this first line here, we are importing this library like in JavaScript. We import the library and the functions that we want. So we are importing this prelude and then everything from it. We have this notation here, which is basically telling the code that everything under this declaration here of the was_BindGen will be like something that will have this interoperability. So we're telling the code that we're gonna have an external function called alert that will receive an S, which is a string. Basically, we're just using the alert from the JavaScript. Then we declare it again, and then we're gonna declare a public function called add. That basically will receive two numbers and return a number. But in the middle of this function, we're gonna use this alert that we just declare here and call from the JavaScript. So basically, we're just declaring this variable here called result, which is a number that will be the result of the sum from A plus B. And then in the alert, we're just gonna format it using this macro here that is from Rust, concatenating this result string with the result of the sum here. And then we're gonna use the alert. So from the ones who is comfortable with JavaScript, know that in the browser, it will pop up a box with the result, the string, and then the result of the sum. And we're gonna return the value of this result. So after that, very straightforward, we're just gonna run the command was_unpack build, targeting the web. we can target this code for a lot of other platforms. So as we're gonna use it on the web, we just target the web. And then we're gonna have a structure like this. So as I mentioned, it's a very simple example here that we have, where basically we're gonna have this structure here from source to cargo, TOML, which is the one that have been created by the first command that we run. And then when we run the build, we're gonna have this package here with this whole structure, which basically have the JavaScript code, the WebAssembly, and the integration between the WebAssembly and JavaScript using the WebAssembly API that we have in JavaScript. So after that, I just create a simple file here, index.html, and this is the file that have the simple structure that will be responsible to integrate the code that we just built with the WASM pack, and we're gonna integrate it here with our JavaScript. So we start using Rust, build it through the WebAssembly, and right now we're just integrated with JavaScript. So very simple, very straightforward. We're just gonna import these two functions here. The first one is init, which is the one that will kind of instantiate the instance of the WebAssembly API. And then after that, we'll be able to use all the functions that we just developed there. So here's the add function that we just create. And then I just create this function here, which is a sync function called run that will instantiate the WebAssembly API, and then gonna call the function add, passing 21 plus 21 as parameter, and then this constant result here, it will just be declaring we receive the result of this addition here. I'm not doing anything with this result. I guess I should console log it, but as we have the alert, I didn't need to have like a console log to show the result of this function here. And then at the end, I just call the function. So as a result, we do have here, and that's it. I guess that's it. So the main goal here was like to create and to show that it's not that difficult to go from one language to another one using the WebAssembly. In this case, I use the Rust because it's what the integration with WebAssembly, as I mentioned before, is more like well documented. I guess it's more advanced than the other ones, and we can use this as a new tool to our toolbox. It doesn't mean like we need to change the whole code and we need to go through this new technology and go like crazy about it. It's just like a new possibility for us to bring, especially when we have like high cost applications, like something that run the browser, for example, Figma that we would use a lot. It use the WebAssembly. This is one of their strategy. They use like React in the front end as the front end framework, and then lib, sorry, and then they use the WebAssembly to run the most performatic tasks. So I guess that's a wrap for the application. Thank you, guys. And right now, QA time.
Thank you very much. Google Earth is also a really good example with the WebAssembly.
Google Earth.
Yeah.
Right now they changed the AutoCAD also, which is like a 30 years old application. They just converted to the web right now. So
Everything can run on the web now. Browsers is the future.
bro.
So, questions?
Hello. So I saw that a package.json was created when you compiled. Can you use that to like publish the package to a register and then import that from like npm, or do you need like all the WASM code, and or can you actually do that?
In the real scenario, you're gonna probably need to publish this this package and then publish into the npm, and then you're gonna need to install it and then use like we use like some other external libraries. But yeah, you're gonna need the WASM, of course, but it needs to be published to be used like externally.
But is the browser the one that is going to be handling the WASM file in this case? Okay.
JavaScript engine running the browser, which browser you select, will be the responsible to convert it.
I imagine that the .ts was the types file, so that you can, yeah. Nice. Yeah, very nice. Any other questions?
Sorry, guys. Questions, but yes. Cuckoo, it will be interesting for everyone. Could you back to the Rust code, please? That result, this is only for the log?
Yeah, this result is just because I returned the value, but I didn't use it. I actually use it here on the calls result, but I didn't use on the JavaScript. Just for the sake, if I want to use this result, it will be returned from the function.
The doubt is probably around the syntax of Rust. If you put the variable at the end, it basically returns the.
Okay. Other question is. I tried to do some tests a few months ago, and I had a lot of issues when I'm using a type of variable or a variable on JavaScript, and everyone knows JavaScript is a wide world. But here, when you pass a type, how do you can manage which type you will pass correctly? Because sometimes, if you are using TypeScript, TypeScript will alert or
Like the type is different from the one that you declare.
yes.
Yeah, so in this case, in this file here, we're gonna have the types. So if you are using the TypeScript, it will like show as any other TypeScript application. If it's in JavaScript, it will happen like in the JavaScript, it will have an error in the runtime.
Just one more. Sorry. This is easy to integrate with the most famous frameworks. Like, okay, I can just import my, I don't know, sort functions on my React page.
And that was the goal here, like to use vanilla JavaScript, because as I use it here, you can use like in any other framework like Angular, Vue, React, or any other like technologies that you're using with JavaScript or TypeScript. So
you should create the build considering this, right? Because
framework I'm gonna use at the end? No, because at the end of the day, it's JavaScript. So whatever framework or lib that you're using, if it is in JavaScript, you don't need to think about it. The only concern that you have is target web. When we target the web, we're gonna render this code, we're gonna compile this code to JavaScript, and then it will be available for you to use in any of these frameworks or libraries that you want to use on the JavaScript side.
put in the okay, thank you. Great presentation.
Thank you. Any other questions? Okay. Thank you very much, Rafael. So, as you remember, there is a break time now. So we'll be back at 8:30? 8:20? I'll call you. Right.
share time, it will be cheaper instead of writing the phone.
There might exist tools, but like
Thank you very much.
Vou-te só dar assim uma quick intro. Alguma coisa que queiras? Pronto, aqui estás setup, não é?
não, era muito isto. Estava a testar o Zoom.
Ah, ok. Okay. Whoa. So, welcome back. We're back from the break now to speak about Tauri. I hope the break was good. So, thank you very much to Mercedes for helping us and hosting us again. So now, without further ado, Carlos, let's talk about Tauri. Yeah?
Yeah. Hi everyone, good night. So I'm Carlos. I'm an independent contractor working with YLD. And we have been in a client working with Tauri to build an app for writing text. And with AI, and the requirements were such that we had to write a desktop app, multi-platform. So we got into Tauri through that. So, and this talk is about in a way, our experience and allow you to know what we can do with Tauri and take advantage of Rust, as we saw in the other talks. So my idea is to share, in a way again, sorry for that, given the previous talk, what are the main goals or the main characteristics you're going to get using Tauri as a platform, and then some features you can use in Tauri, and a demo with code to feel how it looks. So Tauri is an open source, free for use framework. Someone asked, yeah, this is free. Designed to build cross-platform desktop applications. It's not actually only desktop, it's to build applications, even without UI, I would say, to a certain point. And the key features that they recognize are being flexible, fast, lightweight, secure, and cross-platform. So now what this means. So what is being flexible? So being flexible is being agnostic of what you're going to choose to build the app. Of course, there is a strong Rust baseline, but after that, you can choose for the front end known technologies from the website based in JavaScript, using web technologies, even WebAssembly, for example, and or even Rust. So there is a lot of flexibility on that side, and also advantage because you can take advantage of knowing such technologies, so that you can use your preferred tools to work with Tauri, adapting to the project requirements, etc. So it's good for that. In terms of being fast, so I think that in a way, no-brainer given what we spoke. Yes, Rust is maybe the faster on the market currently, and that's also the way they built Tori, the tooling around the building process. You're going to see aspects from the way we opt in for using certain features. It makes it faster because the footprint is smaller, hence faster, and with other advantages. And also, as was mentioned before, the benefits of, for example, zero-cost abstractions, so that you can be on the edge of the performance, because those abstractions now have zero cost for you when running the code. In terms of the UI-facing side, and if you think about other competitors like Electron, what they say is that they can provide a faster solution in a way that they use the native web render for the browsing capabilities. The third characteristic is being lightweight. So being lightweight is very important for an app. For everything, even for the web, we know we are always trying to shrink, to minimize, to ensure that the images have the threshold right between the accuracy and the size. And Tori makes a huge effort on producing such binaries, very small. We're going to see what's the size of an app. That can be huge as you want, because you can embed other libraries or other tools inside your deployable. But you can get like an app in 600K, okay, below 1 megabit. I won't show that one because you need to activate certain elements and the app needs to be reasonable simple. But the baseline is quite small. So you would think, I don't know, like comparing with Electron, that you get more than like around 100 megas, just baseline, because of the way they built. I don't want to go to that point because they have their reasons, but we're going to see like 5 megabytes for these. And that's important when you think about an app that's going to be downloaded, going to be updated, and therefore, if you reach a massive audience and you store these in a storage, you're going to pay for the download size, most likely, and that can become an issue. It was actually. There are stories about that. Not for Tori, but for other projects where they got viral and they got issues paying for the traffic in the storage. So we can do that by optimizing the compilation of application features. Okay, and we're going to select opt-in for certain features, and that would make taking advantage of Rust compiler, that amazing compiler, and the ecosystem, making the most lightweight, smaller application. And also, again, not having to also deploy the browser or the web render, it's a big deal because you don't need to send those bytes, and it's going to be updated, etc., by the operating system. Security, it's always important, right? It's everywhere, and this is front of mind for the Tori team. They do use Rust, and Rust has, as we saw, like for threading, for memory allocation, sharing data, etc. It's safe, like bird design, I would say. The code itself, and you're going to see, if I try to access the file system, error. If I try to open a model, error. So it's secure by default. So you need to be explicit on your intentions, even to go browse and do a a HTTP request, you need to explicitly say which APIs, let's say you have an external API, you're going to use. The communication, so there is like the backend in the front-end concept in Tori. So the backend is the Rust code that it's kind of your goal, because if you are using Rust and Tori with Rust, one of the goals is having certain parts of the code that have requirements for the performance, or maybe a system call, etc. So that part needs to communicate with it's called the front end, the user interface. And the communication between these two worlds, most likely you're going to use web technologies for the front end and Rust for the back end. It needs to be secured. And it's quite simple. It's a message passing technique where you need to serialize the payloads of the request and the response, but it's effective and it's secure. That's what's important. Also, I think it makes sense to say that they are conscious of making security audits for their code base, horizontal, where they test all the libraries that they use, and also vertical to see penetration errors, etc., by external teams, and they publish the results. Finally, being cross-platform. I think every time we want to build something that we're going to show to everyone, if they have Linux, Windows, or Mac OS, in the future, supporting also Android and iOS, those devices. So it's not only desktop. So currently, Tori is on version 1.6, I guess. It's 1X. They are working very hard on the version 2. There is an alpha channel on the version 18, I think, or something like that, for a long time that you can opt in and use right now. And they are actively supporting working to support Android and iOS. And it's quite simple. There are some challenges for like, oh, what you're going to use as like the bridge for existing code. Yeah, Kotlin mostly for Android would be nice, or Swift for iOS. They are also working on that part, okay? Moreover, there is like a company, Krag Nebula, that is that was made by the core developers. So they joined forces and they created this company that is even making Tori stronger in a way that they would provide services for deploying apps, to sign apps, etc. Also, like with the business model, then you're going to pay for their services. But maybe there is the right trade-off for like indie developers to build their apps as fast as we can build in Tori, because that's very important, I guess. I think it's the most important part of Tori. Comparing with Electron, I tried. I'm not that young, not that easy for me to try stuff as before, honestly. So kind of reading through the ecosystem of Electron and doing stuff, maybe it's not something I liked, but for Tori and with Rust, it's super easy. And it felt very well. I kind of, after preparing this, now I want to do Tori apps to learn Rust also, because my background is also in C. I was sharing that with Miguel before today. So maybe you also are with this mindset, like, oh, let me try Rust through the UI, because I'm a UI person and I want to see like interactions, not through the command line, for example. So these are the main core features of Tori. The architecture is super simple. I just copied this from their website. It's just to say that they have like these three main parts: the core, the RAI, and the TAO. So, and the Tori core is like the. Oops, I have something. It manages the execution of the application. It's like the platform and connects everything together and handles the interaction with the system-specific parts that need to be implemented by for the different platforms, like the window management. You can guess that they are different across Linux, all the Linux variations, and also the WebOS, the macOS, and all the others. And that interaction needs to be done by someone. It's done through Tauri Core into the next topic, that is the RAI. It's so difficult to say this. I don't even know if this is the acronym for Web Rendering Library. Maybe not, because the TAO is not such an acronym. But it's a library they have. It's the abstraction layer for just pointing and like adapting the web view, because we know there is like when in the front end I want to invoke Rust, I'm in the web view space. So we need to augment the environment, the JavaScript execution, to be able to interact like with the Tauri. And also the wrapper around this is the TAO. The TAO is just, it's another library built on top of existing code, proved like Winit, and they extend with a menu bar and system tray. Because some systems don't even need to deal with menu bars and system trays, so they have had to implement that. So these three elements you generally don't need to care about. So, and that's very good about the Tauri system. Maybe if you build it the last time, you're going to read this, otherwise in the documentation. So let's go to features. I'm almost there. Next slide is about demo. So before that, so what can we build? Which features Tauri offers? Everything you would expect. Maybe sometimes you won't get what you want. I will explain in a bit. So what can we get? Self-update, very important nowadays for the app. Okay, the web is always updated, but the desktops aren't. So there is a mechanism for that. Plugins, because yes, we're going to share code, and code that is Rust code that has like to interact with Tauri in a certain way. So like think about authentication and authorization. For that they have, for example, a plugin, an event system, so that you can also receive in the front end notifications from what's happening in the back end. For example, think about the back end as when you go to a menu and you click something, that's an interaction that comes from the back end in a way. And all other aspects you can do with the events, because they are multi-producer, multi-consumer, and they work across the two spaces, front end and back end. Then application icons, yes, they have a solution. You just need to upload something that is very simple, but if you think of application dimensions, different sizes, etc., they can build that for you. You just give an icon, and they produce all the variations that are required for the application icon. Then, yes, we can have multi-windows. So I'm going through these from left to right, top to bottom. Multi-windows, you can open different windows, manage those windows. You can have then window API with the borderless and everything related with Windows, including the menu. Okay, configuring new entries. We're going to try that. We need to write Rust code in version 1 for that. So that's why I have this paper. I think it will be fine. And application tray, because your application can live in the tray and be very useful, because taking advantage of global shortcuts like command space, that's an application in a way. Like, yeah, we can, I think, even replace this in Mac. Also splash screen, so that you can see something while the application is still loading. File system that is scoped. So again, security concerns. Application storage that is also platform aware, because where you save temporary files in Windows and Linux-based systems or macOS, it's completely different, but we can access agnostically to those for sure, because otherwise it won't be platform agnostic in a way. And also notifications, a sidecar pattern, maybe you don't know what this is, it's very important. It's being able to embed in your application a different application. For example, going back to the example for RevStudio, RevStudio is the application we implemented with these. We've had like a data engineer that was working with the AI. That's normal, having to write in Python. So how can we join these two worlds? Okay, we can have a Python script, a Python application that we bundle inside, and we use the sidecar pattern to call that application. Okay, and we have multiple ways of controlling the life cycle of these applications, etc. So that's using the sidecar pattern and in a way the Commons API. The invoke API, it's for calling from the front end the back end. That's going to be in the demo right away. So I will speak more about that in a second. And also even command line applications, there is support, among others, that you will find. I think this is just, it is already a long list. So let's do some code. Yeah. Okay, I think I can call these. So in the terminal, you can see these on the, first you need to install the prerequisites, like Rust and other like X, if you are in the system, X code tools, etc. But after that, you can use Yarn, for example, create, and Tauri app, and it will create, it can be also with the NPX. Ignore this is my machine, you shouldn't have these errors, but they are like, this is optional, don't worry. It's working, it's gonna work. So let's give it a name. So LX, to be short. Then we can choose in this interactive way, if we want to go wild and use Rust all the way, I want, or TypeScript, JavaScript. So for that, I'm gonna choose, we don't care actually. So it's Yarn, and here to be a bit more advanced, let's say React with TypeScript. It's okay, so that we have more code. So what the tool did, created a skeleton of the project. So we can go to the LX, and we can code these. Its size okay? Okay, so the app, it's super simple with like scripts to start the app, as you would expect, like in a web-friendly project, you would see package.json with the scripts to start. The most important is Tauri. That is a gateway to the Tauri command line script to build, to start the development server or development mode, and also some dependencies, also for TypeScript. And then you have these two folders that are the important folders with the code for Rust, source Tauri, and the source is the source for your UI. I think they should have decided to use source UI and source Tauri or backend, but it's okay also. So you will find this super simple code in Rust. So it's the main, standard main to spin the app. So it will build the Tauri app, telling him that we have a command named greet, and you will run the app. So it will show the app. So this is making, using the macro Tauri command. Yeah, and the documentation in Rust is quite amazing. And you have like a function that receives a name and produces a string. And we are just returning these formatted. So we don't need to return, you just need to not use semicolon in here. So this is the backend code for now. So we'll be able to call in a way to invoke greet and get like a welcome. So let's run this before showing more code. So yarn install, let's not forget that. I keep forgetting these. And then yarn Tauri. Yeah, I'm using my phone. or the Wi-Fi. Yeah. I thought this would be faster. Maybe PNPM would have been. Okay, I know. Yeah. So Yarn Tori, you can always. Sorry, my keyboard. Yarn Tori, sorry, help, and you can see what you can do. Like for example, icon, so that you can build the icon. But why we want to have that to run dev. So here we go. We are in development mode, compiling. Yes, this will take, for a good reason, it will take time. Even in dev mode, we need to have Rust code, and it's the first time. It won't happen always, okay? So, and it's gonna be quite fast, as you see. So this is the app. This is what you're gonna see, and it's super easy, right? HTML with React, a button, and you click, and you're gonna get, like Carlos, enter, hey Carlos. So as you might guess, this is coming from the Rest side. So let's see how that happens. So that happens very easily. So if you go to source, it's super simple, 2 files. The main, that is nothing, it's just a wrapper for the app. And then the app itself, it's bigger than it should in a way, also because of my font size. So we have a form with an input and a button that when you submit the form, you greet. What is this? It's setting the state with the invoke. So this is the part, the glue, calling the backend. So I will make it extract to enclosing scope message. Oh, and now it's complaining about typing, okay? So what's happening here? So, and we spoke kind of in the other discussions about this type safety, and we are calling the backend. Yes, we are in TypeScript, but we don't have magic. And maybe there are tools that I don't know, they should exist, where we can define like a process where we create TypeScript definitions for invoke, okay? In our project, we used, when we were calling the sidecar, the code in Python had a structure, like a proper structure, and we generated TypeScript definitions and a wrapper with generics so that we can not use strings for this, so that we have like a method called greet with parameter name that's super easy to build in your app. So that's kind of a non-issue. What you need to do is know what you are doing, and for example here, doing this. Okay, but this isn't that important. What we need to understand is that we are calling invoke from a JavaScript library that Tauri provides and we can use, okay? So if we want to use different things, or even let's create quickly in Rust a different comment. We just need to create a comment. Let's call it like power of 2. We can even use this num, that is a number, and we gonna return a number. And we have, sorry. I'm thinking too much with my keyboard. Yeah, my keyboard is in English and I'm typing in Portuguese. It's always a mess. And I use an external keyboard. So yeah, the code is running. So it should be fine, as he mentioned. So my code, I think this should be the way we do exponents in Rust. We just need to make sure that we use that library, that function. We expose to the calling party. So we do this. So we just need to state that they exist, okay? And let's transform these in that code. So instead of the greet message, what can we do? Like let's input a number there. Maybe we can input a number. And here we call, instead of this, power of 2, for example. with an underscore. Okay? So you're going to find, thank you, I'm going to make another mistake. So this is a string. Let's see if this works. Oh, by the way, I didn't recompiled. So I didn't, because all the things you would expect from a modern platform, let's say, developer experience, it's implemented. So hot reloading for the web without Rust having to reload. And also, if you change the Rust side, you would make these, like the app restart automatically. So 3, we called read, and we got error. So we got an error, or this isn't working, okay? So can we know what's going on? Yes, so we just need to inspect element, and don't forget we are like in the web, in a way, inside an app. So you have all these tools for your use. So unhandled promise rejection, yeah, invalid arg num. So the first error is actually I'm using name, and I shouldn't use that because the specification is like to use num from a name. Sorry, this code is quite bad, but. And now what can we do? Did I forget anything? You see? So even with this, I'm getting an error of giving a string. So there is some contract, some type safety, even with this light protocol of message passing, okay? So they understand objects and basically JSON, I would say, in a light way, okay? So let's make these with a parse int. Maybe the worst code I did so far. And we have 0. Amazing. I'm not the best. It's return. We need to return? What? It's right? Is this the power?
That's short.
What? That's short, right? Okay. Returns power. So wait, I have Copilot. So it's restarting, and now it should work. Yeah, that was. And actually, yeah, as a side joke part, Copilot is good for this. You are, I don't know, and if you say what you're gonna want to get, you can do this. So I think we are kind of over time.
Yes.
So sorry not having more to show, but yeah.
We have time for one question. So, hands raised. Okay. I'll make my question then. Can you compile to mobile?
Can Tori Rust? Yeah, yes. Not in this version, so I'm in version 1.6, 1x. But in the next version, you can just like yarn, create Tori apps minus alpha, something like that. It's very easy to find, also in the documentation. And then you can target to a mobile.
Okay, thank you. Okay, I guess one question. Since it's not from me.
Yeah, just regarding the declaration of the function that you create in Rust and then you were using in React. Do you need to use like the same name of the argument? Like in this case, you use num. Do you use
exactly the same name, and that's quite annoying. But I think it's only annoying when you are starting, because as you build an app with a capital A, you're gonna need to build tooling that generates code that connects these two worlds.
You just need to look at the fact that you're passing it like an object.
Yeah, it's an object.
If you're passing an object, you need to match the order of the arguments.
Yeah.
And also because for TypeScript, it's easier to type check.
Type check on a type with the structure of the payload than like on arguments, floating arguments in the function declaration.
But Tori can definitely improve on the type errors within the code editor in there.
Yes. Yeah. But you got very good errors, right?
Yeah.
In the from the backend. So it was quite amazing.
Right. Thank you very much, Carlos, for your presentation. And thank you all for attending Require LX. See you next time. Bye-bye.